In the problem number 5, we have to compute a number of requirements. First requirement, we have to compute their arithmetic mean, and the very next requirement, we will see how to measure the standard deviation, and then we will be computing the problem or the requirement, which is the coefficient of variation, and last requirement, we have to compute the geometric mean of two stocks, stock T and stock B. And also we have to make some of the decisions how we can choose preferable stock or desired stock between stock T and B. So initially we have to write the problem number 1, where we have to compute arithmetic mean. Arithmetic mean is also called shortly as AM. And first stock, as I said, that stock T, there the arithmetic mean we can write R bar, and stock T, R bar means the arithmetic mean, or it is the symbolic form of arithmetic mean, we can say. So R bar T, the formula, as you can see there, sum of R T divided by N. So return of each of the year for stock T, and that should be sum, and then divisor we have to consider here N, I mean number of stocks written, or we can say number of years or number of variables, whatever. So here we have given different years, I mean total 5 years data on the return of the stock T. There you can see 0.19 is the first year return, and then 0.08 is the second year return, and in third year minus 0.12 it is the negative return, we can see in the problem, and then fourth year it is minus 0.03, and last year in the fifth year it is 0.15. So we have to first of all input data from the problem, and that should be divided by 5, as I said, that number of years or number of variables or number of returns. So if we sum, then it should be 0.27, and we have to divide it by 5, and after division we will have 0.054, that should be multiplied with 100 to show in percentage as the rate of return, so we will get 5.4%. So this is the way that we can follow to compute arithmetic mean for stock T. Now come to the computation, similar way for stock B. Same again, R bar B, I mean arithmetic mean for stock B. There we can write sum of RB and divided by number of years or number of returns. So B number of returns, as I said, in there you can see that B 1, 2, 3, I mean number of returns, as many as return we have to just sum there in the numerator. So for first year we can see for stock B it is 0.08, then second year it is 0.03, and next year we will see there minus 0.09, and then next year fourth year it is 0.02, and for fifth year it is 0.04. All the returns we have to input in the numerator, and there we can see that denominator it is n equal 5, total 5 years, or number of returns we can see there 5, so we have to write as 5. So if we sum the numerator, we will have 0.08, and that should be divided by 5. So here after division we will get 0.016, and to show in percentage, as I said, it should be 1.6%. so this is what actually we have to compute arithmetic mean using the formula you can see there. So this is what actually you have to follow while computing arithmetic mean. So if we want to make decision in the problem number A, I mean requirement number A in the problem number 5, then we can say that stock T is desirable. Why stock T is desirable? Because if we consider the output or result of stock T, it is 5.4%, and for stock B it is 1.6%. So it is higher than stock B. I mean the return of arithmetic mean return or annual arithmetic mean return is higher than stock B. So stock T is acceptable or desirable stock for investor. because it provides higher return than stock B. So we can say that stock T is desirable than stock B because arithmetic mean return annually of stock T 5.4% is higher than arithmetic mean annually of stock B is 1.6. So this is how we can write a few words to conclude this requirement, first requirement. Now we will see computation of standard deviation in the requirement B. As you can see there, we have written already that standard deviation, which is shortly written as SD. So for stock T, and as we know that standard deviation is symbolically written as sigma. So there you can see that sigma T, I mean standard deviation measures the risk, so risk of stock T or sigma T. So the formula we have to follow here to measure the standard deviation or the risk, the root over and then sum of RT, I mean individual years return minus R bar T, I mean mean return of the particular stock here T, and it should be whole square, and we have to divide it by n minus 1. Here we have subtract 1 because we have considered this data are sample data. So if we find that sample data, then we have to just subtract 1 from number of observations or number of years. So we can see n minus 1, this is the particular formula we have to follow in this problem or in this requirement to compute. So now we have to just input from the data given in the problem. So we have to whole root all of data. So here you can see 0.19 is the first year's return, and here also you can see, so first year return is 0.19 and we have to subtract the mean return. So we have for T the mean return is 0.054. So we have to every time for 5 years we have to write same average return or mean return, so 0.054 whole square plus 0.08 minus 0.054 whole square plus next year return, I mean third year return, minus 0.12 minus 0.054 whole square plus minus 0.03 minus 0.054 whole square. In this way last year 0.15, I mean fifth year return, individual years return, 0.15 minus 0.054 whole square. So in this way we have to input data and we have to divide by 5 minus 1, the value of n is 5, and we have to subtract 1, as I said, that sample data we assuming. So in this way we have to just input. Now we have to sum and square every year's data. Then if we sum, then we will get 0.0657 and divide by 4 because 5 minus 1 it makes 4. So we have to divide it by 4. And after division we will have 0.0164, and after root over the value should be 0.1281, and to show in percentage we have to multiply once again 100 by 100. So lastly we will get 12.81%. So 12.81% is the standard deviation, or we can say risk of the stock T. In this similar way we have to compute standard deviation for stock B. There you can see the same formula, just we have to write here symbolically B for stock B. So sigma B root over sum of RB minus R bar B whole square divided by n minus 1. Similar again. So now we have to just input data of stock B. So first year stock return is 0.08, so we have to write 08 minus the average return or mean return of stock B is 0.016, I mean 1.6%. So we have to write 0.016 whole square plus next year it is 0.03 minus 0.016 whole square plus next year third year it is actually 0.09, I mean minus 0.09 minus 0.016 whole square, and in this way I mean fourth year and fifth year's data we have to input, and then we have to divide it by 5 minus 1, and just we have to use our calculator to compute the numerator value. So if we compute, then we will get 0.0161 divided by 4, and after division it should be 0.004, and after root over we will get the amount 0.0632, and to show in percentage once again it should be multiplied with 100, and then we will get 6.32%. So 6.32% is the standard deviation or risk of the stock B. So this is the way that you can follow to compute the standard deviation or measure the risk. So if we want to just make decision after computation, then we can see that stock T, it has 12.81% as the risk or the standard deviation or the sigma value, and for stock B it is 6.32%. Higher standard deviation is not acceptable or not preferable or desirable. We will consider the lower percentage of standard deviation, because as the higher percentage of standard deviation shows the higher volatility or higher risk. So we will select that stock which has a lower percentage of standard deviation. So between two stocks here, stock T and stock B, we can see that stock B has lower percentage of standard deviation than the stock T, which is 12.81%. So here we can write few words that stock B is preferable than the stock T on account of a standard deviation of stock B, which is 6.32%, than the standard deviation of stock T, which is 12.81%. So in this way you can make a decision or comment after computation of the requirement. So now we will see how to compute the coefficient of variation in the next part. Now in the requirement C, there you can see that coefficient of variation, it is written shortly as CV. So we have two stocks, stock T and stock B. So for stock T, it is CVT, and the formula, as you can see, it is the relativity of the standard deviation and return or arithmetic mean. So mean return. So there you can see that sigma T by R bar T. So there you can see we have just input the value we have computed in the requirement B. Their standard deviation for stock T, it is 0.1281. So 0.1281, and that should be divided by arithmetic mean or mean return. So mean return here for stock T is 0.054. So here 0.054, and after division it should be 2.37. And for stock B, as you can see, it should be CV for stock B, and we have to write there in the numerator part the sigma B, I mean standard deviation for stock B, and that should be divided by R bar B, I mean the mean return or average return for stock B. So we have a standard deviation in the computation for stock B. We have already computed. So it is 0.0632. So you have to just input there 0.0632, and that should be divided by the arithmetic mean of this problem, which is for stock B, and it is 0.016. So 0.016 we have to input here. So after division we will get 3.95. So here this measure actually shows that the stock T is preferable because it has lower amount of coefficient of variation. So we can conclude that stock T is preferable than stock B by this measure due to the lower CV, which represents the lower risks. And as you know that for the investor, if it is lower risk, then they go for making investment decision, and for this measure we will just prefer stock T than stock B, because stock B has higher CV, which shows that higher volatility or higher risk. So between two stocks we will go for stock T. So in this way you can also compute or measure the requirement of coefficient of variation. Now we will move forward to compute last requirement, requirement D. There we will see how to compute the geometric mean. Well, in the last requirement, there you can see that geometric mean, which is written as GM. Therefore, for stock T, GM for stock T, and the formula precisely you can see there that pi 1 divided by n, it is the power minus 1, and pi, where we have written as the product of returns, And details formula, if you want to know, then we have to write like this formula, I mean extended formula, where 1 plus return 1, 1 plus return 2, 1 plus return 3, in this way. For nth time returns, we have to just multiply each other, 1 by n minus 1. N represents the number of returns or number of variables or number of years. So this is basic formula that we have to follow while we are just making the measurement of geometric mean. So for stock t, we have first year return 0.19 in the problem you have seen, and second year it is 1 plus 0.08. Then we have negative return, so plus minus, we know that it should be minus, so 1 minus 0.12. And next year also we have negative return, which is 0.03, so we have to write 1 minus 0.03. And last year it is 1 plus 0.15, so we have to write there as power 1 divided by 5. Total number of returns we have 5, so we have to write there 5, and we have to subtract also 1. So now if we just compute and multiply each of the element, then we will have 1.2588 using our calculator, and 1 divided by 5 as power minus 1, so we will get 1.0471 minus 1, and subtracting 1 we will have 0.0471, and we can write it is as percentage 4.71%. So very simply we can find out geometric mean, as you have come to see already. So for stock B, very similar thing we have to compute for stock B, the geometric mean. Here first year return we have to input 1 plus 0.08, then next year 0.03, so 1 plus 0.03, and third year we have negative return, so we have to subtract from 1, so 1 minus 0.09, and next year it is 1 plus 0.02, so it is 0.02 is the fourth year return we have, and last year it is 0.04, so 1 plus 0.04, and we have total number of returns or number of years 5, so we have to write here 5, then we have to subtract 1. Now using our calculator, same again, we have to just compute each of the element and multiply each of them together, and we will just write here 1.1306, and power, there you can see 1 by 5 minus 1. So if we compute this, then we can write 1.0249 using our calculator, and subtracting 1, the value should be 0.0249, or we can write 2.49%. So 2.49% is the geometric return for stock B. So comparison between two stocks, stock T and stock B, we can consider that stock B provides higher return than stock B. It is 4.71%, and stock B provides 2.49%. So stock T is more preferable than stock B due to higher return. So in this way you can compute geometric mean. And now we will also discuss some of the things that in the problem we have been asked to discuss or to make a decision. So let's see how we can discuss those things. Here in this table we can see the difference between arithmetic mean AM and geometric mean GM. Therefore stock T and B, where arithmetic mean is for T 5.4% and for B it is 1.6%. On the other side, geometric mean GM, for stock T it is 4.71% we computed, and for B it is 2.49%. So difference between AM and GM, you can see there for T it is 0.69%, and for B it is negative, you can see minus 0.89%, and the standard deviation for the stock respectively, for T it is 12.81%, and for B it is 6.32%. In short, we can say that for stock T, it is AM is greater than GM. In details, the arithmetic mean 5.4% is higher than the geometric mean 4.71%, which is consistent with the general principle due to the volatility where standard deviation is equal 12.81%. Secondly, if we want to discuss about the differences in mean returns relative to a standard deviation, then we have to say the difference between the two stocks lies primarily in their risk return profile, where stock T has a much higher mean return, both arithmetic and geometric, than stock B, but it is also has a much higher standard deviation, 12.81% versus 6.32%. This means it is the higher return, higher risk investment. While stock B has a lower mean return but significantly lower volatility, it is a lower return, lower risk investment. Finally, a risk-averse investor would prefer stock B because of its lower volatility and generally a smaller difference between arithmetic mean and geometric mean. In contrast, a risk-tolerant investor would likely prefer stock T because its higher returns, when adjusted of risk using the coefficient of variation CB of 2.37 versus 3.95, which indicate it offers better compensation for the risk taken. So finally, we have come to an end of today's class or this problem number 5. Hopefully you have come to learn how to compute these requirements. So for today, it's very goodbye. Hopefully we'll be meeting in next some classes.